here, Chopper Bob Customs, and work continues on the JD's Garage's CNC plasma table. If you are a subscriber, thank you very much for subscribing. I want to thank you for watching the videos. If you haven't subscribed, I ask that you consider subscribing to my channel. I do a lot of interesting things, at least I think. If you don't think so, leave me a comment. Like my videos by all means, and if you're following along on some of these projects, hit that notification bell so you know when the new video is coming out. Like I said, this is JD Garage's plans on a CNC plasma table, and what I've done is I've gone ahead and had a pan broke. I'll get into that in just a little bit here, but we're getting close to the point where I'm going to fire this thing up and start cutting parts. So keep tuned, and we'll go from there. Okay, so I'm going handheld. So get your Dramamine, and I've got one of the reasons I'm going handheld is my wife is out there splitting wood, so I've got to be loud enough to talk over the wood splitter, and but what I've done is, okay, the JD's Garage's plan is a little bit smaller than this, and he has instructions in the plans on how to increase the size of your table, and that's what I decided to do because I wanted something a little bit larger than what his plans call for. The thing about it is, in his plans, he uses a stainless steel appliance catch tray that goes under like a freezer or a washing machine. It's 2.5 inches deep. It's stainless steel, and I think it's 28 by 30. Well, that wouldn't work on this table, and I thought about going with stainless steel. One, I'm not exactly sure if I'd be able to get the clean brakes on it, and two, I'm getting to the point where I need to get this machine making me money instead of it costing me money. I had this piece of 18 gauge sitting in the back that I needed to do something with, and so I checked what size it was and realized I could make a pan out of it. I've gone ahead and cleaned it up because it did have some surface rust on it. It has been sitting around a while. It is carbon steel. It's 18 gauge. My intent is, everybody says you can run the soluble machining liquid in the water, and that helps prevent rust, and so I'm going to give that a try. The thing is, if I get this up running and it starts making me money, maybe I'll be able to afford a stainless steel pan. In the meantime, I think this one will work. I cut it out over here. I checked with a good friend of mine, Tim Hawkins, and he had a large box and pan break. And so I took the piece over to his place, and he and I broke it out. Tim's a great guy. Tim has Waterloo Auto Parts. If you're in the greater Guthrie area, you need to check out Waterloo's Auto Parts. He's a independent Napa dealer, and other than the fact he helped me out with breaking this, I get nothing to promote him like that. He's just a good guy, and if you're looking for Napa Auto Parts, like I said, in the greater Guthrie area, you need to go talk to Tim and his crew down there. I'll have the link in the comments below. I'll probably put it up here as well somewhere. Yeah, right over in here. And but check that out. And thanks a lot, Tim, for helping me out with this. And we got it broke. So what I'm going to have to do is obviously weld the corners, and then I'm probably going to weld a 1/2 inch nut on the bottom side with a hole right about in here, so that I can use a 1/2 inch bolt with a oil pan drain plug gasket, so that I can drain the water out of it. And then obviously I'm going to have to go get the slats, or as they're called at the steel place, steel bar, to build the slats and get that put in there. Some points about the build that aren't necessarily in the instructions. First off, I'm fairly certain, since I based this on the size of the 28 by 30 on the JD's original design is that if it's 2.5 inches tall, in order to clear the printed circuit, the 3D printed parts on the gantry, it needs to be slid over this way. And so what I had to do was I had to take these bolts out and flip them around so that this extra stud area here was not on the inside, so I could slide the pan over this way so that it would clear the gantry. And while I had this apart, as I mentioned in another video, when you look at JD's videos out on YouTube, his holes aren't necessarily round and clean. They're oversized, and I, being the AR guy that I am, wanted everything to be perfect, and so I drilled perfect 1/2 inch holes for the spacers, and I realized after I got the thing built that it really needed a little bit of slop in those for them to function correctly and not damage anything. So while I had this apart over here, I went ahead and elongated the holes on the legs and the x-axis, and the y-axis frame members, so that the spacers slide in and out really easy, and then when you tighten it up, it actually squares the thing up against square tube against square tube, rather than trying to square up against the hole through the spacer. And I think that's going to make it a lot easier for me to get this table square once I get it final set up. The other thing, and I've seen a lot of guys talk about putting a support on this side to support the x-axis arm that's cantilevered out there. And I think, and part of that is due to the fact that I don't think they're able to get enough adjustment out of the 3D printed parts. I've seen guys that are building aluminum ones to go instead of the 3D printed ones. What I found was, and I don't know whether you can see it or not, let me get in here from the other side. The welding of the bracket that holds the x-axis, it moved quite a bit on me when I welded it. I thought I had it clamped and squared up and everything, but it did move. And so now, for at least now, this may be a permanent fix, I've gone ahead and shimmed this up so that I can get this x-axis. It needs to be parallel to your slats in your pan, so that when you're cutting, it's not going up and downhill in the x-axis. But that's something that you need to watch out for. If I had it to do over again, I probably would have locked it down a lot tighter, and I may have put some camber the other way in it, because with the weight and everything, it has a tendency to droop. And with it not being particularly square to begin with, then the droop really becomes pronounced. And like I said, I don't know whether this is a temporary fix or whether this is going to be permanent, but you know, obviously I had some front suspension shims laying around, and I went ahead and put them in there for the time being anyway. So with that being said, what I need to do is get this pan out of here so that I can start welding the corners. Okay, so as nice as it was to get this broke on a box and pan brake, the corners still need just a little bit of work to tighten up the gap and also make the gap consistent. So with that, I'm going to go ahead and start this first corner and tighten up the gap, and then go ahead and weld it. This doesn't have to necessarily be a strong weld. The goal here is to not let the water leak out. Okay, so next thing I got to do is figure out exactly where I want the drain hole to be and weld that nut in. So let me get that set up. All right, so I've got the corners all welded up. What I want to do now is put a drain plug in it. And so I've kind of gone to this end down here. I've come back in a way so that I can slide a bucket underneath there, take the plug out, and it will drain. So now all I need to do is drill the holes, or the hole rather. And then I'll be able to weld it in place. Okay, so now with the nut centered in the opening here on the other side, I'm going to go ahead and tack it and then hopefully seal weld it in so it doesn't leak. Okay, so if you will look at a 1/2 inch bolt, what you'll find is that there is a radius from the mating surface under the head into the threads. So if you just try and screw that into a nut, what you'll find is that it bottoms out on that radius before it bottoms out in face to face on the surfaces that are parallel. And so a combination of a tap and a countersink, actually two countersinks, the 1/2 inch and the 5/8. I managed to get it to where the bolt either touches or almost touches. So when I put the drain plug gasket in it, one thing I did to check it was I put a mark, and then I went ahead and put the gasket on it and ran it down and made sure that it needed to turn some to compress that gasket, and it does. So I think we're in good shape there. 2.5 inches of water, that's not going to be that much pressure on it. But yeah. And so, and of course on the hole, there were some dingle balls in it. Had to run a tap through it to get it cleaned out. But it looks like I've got a good drain plug. So, I think with that, the next thing to do will be to make the slats. Okay, so I made a trip to Albright Steel, picked up some 1/8 inch thick strips. Some of them are 2 inches wide and some of them are 1/2 inch wide, and I'll get into why I did that in just a minute. But basically I've already done some of the cutting. I cut, these are about 40.5 inches long. Now your dimensions are going to be different depending on what size water pan that you've got. These are for my water pan because I did build the unit a little bit bigger than the JD's Garage's plans. So I'm just pointing out that these are going to be the slat holders. There's going to be 2 of those. And I've already cut those to length 40 and a half, I believe they are. I have some work to do to these to make them work. And then I'm also, and what I did was, these come in 20-foot lengths. And so when I went down there, I bought them, and they charged me 50 cents a cut to cut. And when you look at loading the trailer up and taking the trailer down there to get full 20-foot pieces to bring them back here and then wrestle them around here, it makes good sense to me to have them cut it. I think I spent like $8 on cutting, and I probably would have burned that up in gas taking the trailer down there. At any rate, what I did was, this time the 20s, I had them cut into 8, 8s, and 4s. And what that allowed me to do was, the 4s provided for the holders, and then with the width of my pan, I figured that 32 inches was going to be probably pretty close to what the slats needed to be. And so 3 times 32 is 96, that's 8 foot. And so basically what that meant was I'd have no scrap. Now it turns out that I actually need a little bit less than 32 inches, so I'm getting about 3 inches of scrap off of each piece. But if I had it cut in half, I'd have had about 2 foot of scrap that was unusable. So this was a more efficient way to do it. The other thing that I did was, I only need 2 full 20-foot sticks to make this. However, at I think it was $18.95, it was less than $20 for a 20-foot stick. I figure I will have a 20-foot stick on hand because these things do get cut when you're cutting stuff, and you're going to have to replace some of them from time to time. And so now what I've got is, I've got, in essence, 7 slats extra, so that I can, if I got one that's in particularly bad shape, I can pull it out and drop a new slat in. Yes, so what I'm doing is, and I'm not going to cut it now. I figure there may come a need for some of this material for another project, so there's no sense cutting it up until you actually need it. And actually what I'm going to end up with, because I actually need 11 slats, and these pieces are going to give me 12. I'm cutting up 4 of these 8-foot sections, so I'll have 1 spare all ready to go in the first place. So what I found out was, while I was, is that they need to be 31. 32 is just too long, and I'll show you what I did with the one that I did cut. Now, the other thing is, I could have gone in and done the math on this and sized them perfectly, but every time I've done the math on something like this and sized it perfectly, it was all perfect on paper, and then when you got to real life, you had to trim like 1/8 of an inch off. And so I thought, hey, you know what, I know it's about 32, I made the first one 32, I have to cut about 5/8 of an inch off of each end of it to make it work, and save me some math work. The other thing I want to point out is that I am going to be giving it a shot of cleaner at around 15.5 inches and then at 31 inches, just to get the oil off of the surface. And the only reason I'm doing that is I'm using a Sharpie, and that seems to prolong the life of the Sharpie. So I'm going to go ahead and get started cutting, and then we'll get into how this all goes together. So I'm making a mark at 31, and then I'm making a mark at 15.5. And the 15.5 is where it's going to get bent. And the 31 is where it's going to get cut. Okay, let me take you over here and show you what I've got started on this, because I've already done some of the work to make this. Okay, this is the one that I cut that was too long, and as you can see, what I've done is I've put extra bends in it, and the reason being is that you end up with these huge open areas here when you go with the bends. So basically, I'm going to be doing it like that to kind of fill that in. And you want these. They say that slats on a plasma table should be between 4 and 6 inches apart. I'm shooting for somewhere in the 4-inch range because this is a small table. I'm going to be making small parts. It would be nice if they don't fall through, but they probably will on some of the parts, but that's the way it goes. And so what it boils down to is that this was the one that I started off at 32, and I had to cut 5/8 of an inch off of each end of it. And then I bent them so that they've got about a 3-inch hump. So let's go ahead and get the, let's do some bending. Okay, and one of the things about this is JD's garages, they don't have very much information about the slats, but what they do have is really good stuff to know, because the rest of it is just pretty much mindless assembly work. I'm using a vise. He said that basically he just bends his over his knee, which you could do as well. I mean, it's 6 1, half a dozen the other. I got the vise. I don't damage my knee. Anyway, yeah, and so yeah, that's basically what you do 11 times. And there's the rough layout of what it should approximately look like, okay? And I mean, I'm gonna have this area back up in here, and I may address that. The chances of my cutting stuff back up in there is probably gonna be pretty slim anyway. It's probably gonna be big pieces at that end, so I'm not too worried about it. Anyway, so now what I need to do is I need to build the supports for all of this. Okay, so the first thing I did was I established 2 inches at this end. That's on the one that has the 3 bends in it. And it needs to be about 2 inches so that it's the proper distance from the, let's call it the front of the water pan. And then at the rear of the water pan, I came in 1 inch. And what that does is, at 3 inches on the hump approximately, that puts the highest part of the hump 4 inches from the back wall of the water pan. Then measured from that 1 inch mark to that 2 inch mark, and that distance was 37 5/8. And then that meant with 11 slats, that leaves 9. But 9 slats has to have 1 extra space, so that's 9 plus 1 is 10. And so divide 10 into 37 5/8, get approximately 33 3/4 of an inch between the slats. Measure it out, mark them all off, and what you get is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 slats, just like we planned. So go ahead and get those marked. Okay, double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just like we planned. Now, I did put a radius on the bottom of these because the bends on the water pan do have a radius to them, so I did put a little chamfer down there, a little radius. So there is a bottom and a top. This is one of the things that JD's Garages does cover that is pretty important. If you were doing this on a mill to where you knew that you were going to be exactly 1/2 inch from the edge of this plate to the bottom of the groove that the slat is going to fit in, that would mean that the slat 2 inches wide would be sitting 2.5 inches all the way up and down the water pan. When you're doing it with the cutoff wheel, you're not so accurate. So he shows a way to take care of that. So what you want to do is you want to make a cut that leaves at a maximum 1/2 inch at the bottom. 7/16 would probably be a little better. And here shortly I'll show you why that is. So what I'm going to do is I'm going to go ahead and make a mark somewhere between 1/2 and 7, somewhere between 7/16 and 1/2. Okay, so that's the line I need to cut to, or actually onto, when I'm doing the cutting. Now, the next thing I've done is, and I surely hope this works, he says, JD says, to double up your cutting wheel and do it that way. Well, I'm using 40,006 cutting wheels, which isn't going to get me to my 1/8 of an inch. And when I tried to use 2 on here to try and get them centered, the nut and the arbor up here are too thick, and so you couldn't tighten 2 wheels down. They were loose. So I went ahead and put the 3rd one in there, hoping that it's centered up good enough on that middle wheel. I've got it good and tight. I've already had one argument with a wheel of death about a week ago, last Monday. I get the stitches taken out tomorrow. So what I'm going to be doing is I'm going to be cutting this. I'm going to move this over here so that you have a little bit better view of it. I'm going to be cutting into it, down to the line, probably going just onto the line, so I know that I've got a maximum of 1/2 inch on each one of these at the end. We're going to see how this works. Okay, obviously it's going to be painfully slow, but it does work, and let's see if it's going to do good on the oh yeah, that's great. So, instead of videotaping all 22 of these things, I'm going to stop the video here and make all the cuts. So I have to suffer through it, but you don't. Okay, before we move to the next step, I wanted to make sure that this sort of fit. Didn't need any adjustment. It did need some adjustment. I've made most of the adjustments. I'm probably going to have to fiddle with it once I get the next step done. But it's starting to take shape. So on to the next step, which I'm probably calling it a day today, so I'll finish it up tomorrow. It'll be a split second for you. With the fit up verified, it's now ready. I'm now ready to go ahead and start assembling the slat supports. And this is where JD's Garages shines on this. I wish I thought of it. It's simple and elegant. But they don't give you a whole lot of instructions, like I say, on your slats. They leave it a lot up to you. But the one point that he makes is that you really need to have the slats at approximately the same height across the length of the water table. And if you're trying to cut these slots to the exact dimension, you're not going to do it. But what you do is you cut them too deep, and then you take a piece of 1/8 inch by 1/2 inch wide strip, and you clamp it all together and you weld it in place so that now each one of these supports is a 1/2 inch off of the table or a 1/2 inch off the water pan. And yeah, so that'll take care of that. And then to make sure that they stand upright, I pulled it out of the scrap bin at Metals supermarket, some 3/4, it's a little bit too big, but hey, it'll work. 3/4 by 3/4 angle. Got a piece just a little over 2 foot long, so I was able to cut 8 3-inch long pieces out of it, which is enough. And then I went ahead and cut reliefs for the slats, because unfortunately the slats do fall on the cross members of the table. But basically what I'm going to do is I'm going to come in here, got it all clamped down, and I'm going to put just some 1/2 inch long welds to hold it together. There's really no stress on it, it just needs to hold it in place, and it's probably all going to rust out when it's sitting in the water anyway, so let's have at it. Okay, with that, this one is ready to go, and I'm not going to videotape the other one. I don't see much point in doing that. When I come back, I'll be putting the slats in, and we'll see how it all fits. Okay, so there we have it. I've got the slats in. I need to check to make sure that it's not, none of the sides are too high, but I think from the looks of it, I'm in pretty good shape here. It's going to be ready to go. So all I really have left to do is put the cog wheels and the belts on it, and I'm going to be downloading some software to see if I can't get some drawings done. And so the next video I'll put the cog wheels on and the cog belts, and hopefully have some software loaded up in the laptop, and give it a try on cut and see how it works. Anyway, for now, again, please subscribe, please like the video. If you don't like something, comment. If you like something, comment. hit the notification bell. And for now, Chopper Bob out.